The SARS-CoV-2 pandemic has led to the need for extreme sanitation in order to prevent the spread of disease, since many common school supplies have over a 90% incidence rate when dealing with bacteria. During this time, teachers at Galena High School have noticed that their methods of sanitizing school equipment are costly, time-consuming, impractical, and harmful to the environment.
While the usual methods are costly and somewhat wasteful, they are necessary to combat COVID-19. The virus is capable of lasting for up to 4 days outside a host on plastic, and the ratio of students to computers in public schools is 1 to 10. Any case of COVID-19 in a school setting could quickly escalate into a full-on outbreak, even with the hybrid schedule many schools are using.
We aim to create a more effective and efficient method of sanitizing school equipment that saves money and time, without sacrificing the safety of the students and teachers. Alcohol wipes may be cheap, but are wasteful and need to be refilled over time, which costs more money in the long run.
Our design had a few requirements in order to be deemed successful. First and foremost, of course, it has to be capable of killing COVID-19 and other harmful bacterium. But some other important factors are cost-effectiveness, somewhat time-efficient, and since children will be using it, easy to use.
After looking over our requirements, we decided that a UV light would be the best alternative to prevent waste while killing germs. With this in mind, we set out to make several different designs.
Our design ideas ranged from a simple overhead light to an attachment underneath each desk to store keyboards while not in use. Two major design issues we encountered were possible prolonged contact with the invention itself, making the process of disinfecting the keyboards pointless, and the danger that UV light can pose if not protected from
it. Seeing as how our design would be used by children and teenagers, these risks of user error need extra attention, since a child blinding themselves from staring at UV lights is just as undesirable of an outcome as an outbreak of COVID or any other infectious disease our design might combat.
When originally approaching this problem, we had multiple ideas to begin with. We knew that we wanted to create a solution using UV light. When designing these solutions, we had to be careful to not be creating solutions that already existed.
Using UV lights to sanitize surfaces was not a new concept, but many designs failed to provide a platform that would be widely applicable to schools, such as these boxes, or these UV lights which do not take safety into consideration and let out harmful UV rays. The most prominent solution to mass sanitation is alcohol wipes. However, despite solving the problems of the previous solutions, it comes at the drawback of it being damaging to certain materials, and being generally wasteful with how many wipes you have to buy.
In the end, we decided on a model similar to a toaster, with the keyboards being placed in the top before activating the UV lights, which the teacher controls to prevent misuse.
To test our design's coverage of the keyboard, we made a mock keyboard out of cardboard and covered it in beads that change color under UV lights. While not as effective as direct sunlight, the beads did change color all across the board, indicating proper coverage.
Science. Contact transmission is infection spread through direct contact with an infectious person, for example, touching during a handshake, or with an article or surface that has become contaminated. Contraction of the virus or bacteria in question begins with the user, who then contaminates the surface in question, in this case, a keyboard and mouse. Through either direct contact or by breathing out contaminating particles on the surface, the next person to use the keyboard then runs the risk of contracting the virus by using the keyboard. The user would get viral particles on their hands, which could then be transported to the eyes, mouth, and nose, causing infection. Our design will use UVC sanitizing light to deactivate and kill microbes between different uses so that the risk of viral transmission through common surfaces is eliminated.
Technology. Our project will require technology, such as CAD programs, to help design a working prototype. The main technological tool for sanitization in our design will be UVC lights. The UVC strip light will emit light in the 280 nanometer range, which is the effective range for deactivating bacteria and viruses. UVC lights are reusable compared to current solution of wipes, and they save money in the long run. In order to keep the light away from students, we will be using a lid to shield their eyes from harmful UVC light.
Engineering. The creation of a device to satisfy a specific niche was paramount in the design of our prototype. The concept of UV light to sterilize things is not new. Because of this, our product had to satisfy critical engineering requirements. We decided that it would be best to have a mechanism that will lower the keyboards into place to where they can be sterilized.
Math. The main mathematical concern of our project is ensuring that our product is profitable in the long term. By calculating the cost per day of current solutions in a classroom setting and taking into account the likely lifespan of our solution, we can determine an effective price range for our product that allows us the funding to ensure that it is safe and functional as well as profitable in the long term. Furthermore, to successfully design and construct a stable and durable frame, we must use physics to determine load-bearing surfaces and just how well each joint will hold. If any sliding occurs, then friction will need to be taken into account. When taking samples of microbial cultures, we need to consider percent error, acceptable sanitation, and other statistical anomalies with our solution.